Miscellaneous exercise on chapter 8, application of integrals. Question number 1. Find the area under the given curves and given lines. The first one is y equal to x square, x equal to 1, x equal to 2 and x axis. The first equation y equal to x square is an upward parabola. X is equal to 1, x is equal to 2 are straight lines which are parallel to y axis. Let us solve these equations. If x is 1, y is 1. 1 comma 1 is one point of intersection. If x is 2, y is 2 square which is 4. The other point of intersection is 2, 4. Let's draw the figure. 1, 1 point and 2, 4 point. The parabola is an upward parabola. Vertex is at the origin. Let us complete the parabola. The parabola equation is y equal to x square. X is equal to 1 line. Then x is equal to 2 line. So this is the area to be calculated. It is bounded by x-axis. We will do integration with respect to x. And the limits are 1 and 2. Therefore, the required area is integral 1 to 2 of x is equal to 1 line and x is equal to 2 lines are the limit lines. And area under the parabola y of parabola dx. We will substitute for y from the parabola equation, which is x square. And integral of x square is x cube divided by 3. The limits are 1 to 2. 1 by 3 times upper limit 2 cube minus lower limit is 1 cube. 1 by 3 times 8 minus 1. The answer is 7 divided by 3 square units. Now the second subdivision. Find the area under the given curve and the given lines. Y equal to x power 4, x equal to 1, x equal to 5 and x axis. Y equal to x power 4 is also a parabola. Let us solve the equations. If x is 1, y is 1. So the point is 1, 1. If x is 5, y is 5 power 4. 5 power 4 is 625. Therefore, the point of intersection is 5, 625. Let us draw the figure. This is 5, 625 and this is 1, 1. And the parabola passes through the origin. 0, 0 satisfies that equation y equal to x power 4. The equation of this curve is y equals x power 4. X is equal to 1 line is parallel to y axis. This is x is equal to 1. X is equal to 5 line is also parallel to y axis. Area under the curve between these limits. Therefore, the required area is, we will do integration with respect to the variable x. The limits for x variable are 1 and 5. Y from the curve equation is x power 4. An integral of x power 4 is x raised to 5 divided by 5 and the limits are 1 to 5. 1 by 5 times 5 raised to 5 minus 1 raised to 5. 5 raised to 5 is 625 times 5, that is 3125 minus 1, which is 3124 divided by 5, 624.8 square units. Second question. Find the area between the curves y equal to x and y equal to x square. Y equal to x is a straight line passing through the origin. Y equal to x square is a parabola. It is an upward parabola. Let us solve these equations. Y is x square, here y is x, so both are equal. If you cancel x, you have to equate it to 0 or factorize and solve. We get two answers, x is 0, x is 1. Therefore, y will be 0, y will be 1. The points of intersection are 0, 0, 1, 1. Let us draw the figure. 1, 1 and 0, 0 are the points on the curve and it is an upward parabola. The parabola equation is y equal to x square. Let us join 0, 0 and 1, 1 to get the line y equal to x. Area is between these two curves. Let us draw the limit line. Area is between two curves. We will do upper curve minus lower curve. And integration is done with respect to the variable x. The limits for both the curves are 0 to 1 and upper curve is line and lower curve is parabola. Integral 0 to 1 of y from the line equation is x and y from the parabola equation is x square. Integral of x is x square divided by 2 and the limits are 0 to 1. Integral of x square is x cube divided by 3 and the limits are 0 to 1. Half into 1 minus 0 minus 1 by 3 times 1 minus 0. Half minus 1 by 3. 6 is the LCM, 3 minus 2, 1. 1 by 6 square units. Question 3. Find the area of the region lying in the first quadrant and bounded by y equal to 4x square, x equal to 0, y equal to 1 and y equal to 4. The first equation is a parabola, upward parabola. X is equal to 0 is the equation of y-axis and y equal to 1, y equal to 4 are lines parallel to x-axis. If x is 0, y is 0. 0, 0 is 1 point and if y is 1, 1 is 4x square. X square is 1 divided by 4. Therefore, x is plus or minus half. The points of intersection are plus or minus half and 1. Write the x coordinate first and then the y coordinate. If y is 4, 4 is 4x square. Therefore, x square is 1. X is plus or minus 1. The points of intersection are plus or minus 1 and 4. 0, 0 is the origin. Half 1 minus half 1. 1 and 4 and minus 1 and 4. The parabola is an upward parabola. The equation of this parabola is y equal to 4x square. X is equal to 0 is the equation of y-axis. Now y equal to 1 is a line parallel to x-axis. Y equal to 1. Y equal to 4 line. Area is in the first quadrant bounded between these given curves. Here the area is bounded by y-axis, so we will do integration with respect to the variable y. Therefore, area is equal to integral. The limits for y variable are 1 to 4. X dy is the formula. So, x from the parabola equation is root of y divided by 4 dy. Half into integral 1 to 4 root y dy. Half into integral of root y is y raised to 3 by 2 times 2 by 3 and the limits are 1 to 4. 1 by 3 times 4 raised to 3 by 2 minus 1 raised to 3 by 2. 4 power half is 2, 2 cube is 8. Therefore, the answer is 7 over 3 square units. Question number 4. Sketch the graph of y equal to absolute value of x plus 3 and evaluate integral minus 6 to 0 of absolute value of x plus 3 dx. Always absolute value of a linear function represents V-shaped graph. Whatever is inside the absolute value sign, equate that function to 0, x is equal to minus 3. The curve takes a turn at minus 3. Therefore, y is equal to absolute value of x plus 3 can be written as plus x plus 3 when x is greater than or equal to minus 3, and it is minus of x plus 3 for x less than minus 3. Let us draw the table for absolute value function. We will take the value minus 3 and few values more than minus 3 and few values less than minus 3. For minus 3 plus 3 is 0, minus 2 plus 3 is 1, minus 1 plus 3 is 2, 0 plus 3 is 3. Minus 4 plus 3 is minus 1, but absolute value sign is there, so it becomes plus 1. Minus 5 plus 3 is minus 2, absolute value of minus 2 is 2. Minus 6 plus 3 is minus 3, absolute value of minus 3 is plus 3. Let us sketch the graph of this function. Minus 3, 0 is this point, minus 2, 1, minus 1, 2, 0, 3. We will join these points. This is y equal to x plus 3, minus 4, 1, minus 5, 2, minus 6, 3. And this is for x values less than minus 3. Y equal to minus of x plus 3. We should not extend these lines below x-axis because y is absolute value of x plus 3. It takes only positive values. This is the graph of y is equal to absolute value of x plus 3. We'll draw the limit line at minus 6. We have to evaluate the integral minus 6 to 0 of absolute value of x plus 3 dx. We have to split this interval minus 6 to 0 at minus 3. Therefore, we get integral minus 6 to minus 3 of absolute value of x plus 3 dx and plus integral minus 3 to 0 of absolute value of x plus 3 dx. But in the interval minus 6 to minus 3, the values are all less than minus 3. For less than minus 3, we use y is equal to minus x plus 3. Therefore, we get minus integral minus 6 to minus 3 of x plus 3 dx. And in the interval minus 3 to 0, the values of x are greater than or equal to minus 3. So, we will use y is equal to x plus 3. Remove the absolute value and write x plus 3 dx. Now, we will integrate. We can write the integration as x square over 2 plus 3x and apply the limits, or this is a linear function. I can use x power n plus 1 by n plus 1 formula. It becomes x plus 3 the whole square divided by 2, and the limits are minus 6 to minus 3. Similarly, integral of this is x plus 3 the whole square divided by 2, and the limits are minus 3 to 0. Minus half into upper limit becomes 0, lower limit is minus 6 plus 3 which is minus 3, minus 3 the whole square is 9, plus half into upper limit is 3 square which is 9 and lower limit is 0. 9 by 2 plus 9 by 2 which is 9 square units. This 9 square units represents The area under this curve y is equal to absolute value of x plus 3 between the limits x equal to minus 6 and x equal to 0. It represents the area of this shaded region. Fifth question, find the area bounded by the curve y equal to sin x between x equal to 0 and x equal to 2 pi. Let us draw the table for sine curve. If x is 0, sine 0 is 0. If x is pi by 2, sine pi by 2 is 1. If x is pi, sine pi is 0. If x is 3 pi by 2, sine 3 pi by 2 is minus 1. If x is 2 pi, sine 2 pi is 0. Sine curve may not be asked in the exam because it is mentioned in the syllabus that only lines, parabola, circle and ellipse will be asked. 0, 0, pi by 2, 1, pi 0, 3 pi by 2 minus 1 and 2 pi 0. Let us join these points to get the sine curve. We will shade the region. This area A is above x-axis, it will get a positive sign. Area B is below x-axis, it will get a negative sign. So we have to make B area positive by writing the absolute value sign. Therefore, area is A plus absolute value of B. Area A is integral 0 to pi of y dx plus absolute value of integral pi to 2 pi of y dx. We will write y as sin x plus integral pi to 2 pi of sin x dx under absolute value sign, or we may put a negative sign. This area will be negative. To make it positive, we may write absolute value sign or the negative sign. Integral of sin x is minus cos x and the limits are 0 to pi. Here also the integral of sin x is minus cos x, minus of minus is plus, and the limits are pi to 2 pi. Minus of cos pi minus cos 0 plus cos 2 pi minus cos pi. Minus of cos pi is minus 1, cos 0 is 1, plus cos 2 pi is 1, cos pi is minus 1. 2 plus 2, 4 square units. A and B areas will be equal. Question 6. Find the area enclosed between the parabola y square equal to 4ax and the line y equal to mx. We will solve these two equations. M square x square is 4ax. We will cancel x, but don't forget to equate it to 0, which gives you one solution. And the remaining equation m square x is 4a. Therefore, x is 4a divided by m square. If x is 0, y is mx, which is 0. Use this linear function to find y value. If x is 4a by m square, y will be m times 4a divided by m square, which is 4a over m. Therefore, the points of intersection are 0, 0 and 4a divided by m square, 4a divided by m. And this parabola is a right side parabola. 4a divided by m square, 4a divided by m. Let us complete the parabola. This is y square is equal to 4ax, and the line passes through these 2 points, and the equation of the line is y equal to mx. We have to find the region between these two. The limit line is this. The area is between two curves. We will do upper curve minus lower curve. With respect to the variable x, we will do integration. The limits for x are 0 to 4a by m square. Y of upper curve is the parabola minus integral 0 to 4a by m square y of line dx. Integral 0 to 4a over m square. Y from the parabola equation is root of 4ax dx minus integral 0 to 4a by m square. From line equation y is mx. We will remove the constant terms outside the integral. 2 root a integral 0 to 4a by m square root x dx minus m is a constant, integral 0 to 4a divided by m square x dx. 2 times root a, integral of root x is x raised to 3 by 2 times 2 by 3. The limits are 0 to 4a over m square minus m times integral of x is x square over 2, and the limits are 0 to 4a over m square. 4 by 3 root a, 4a divided by m square power 3 by 2, and the lower limit is 0, minus m over 2, 4a divided by m square the whole square minus 0. 4 by 3 root a times 4 power half is 2, 2 cube is 8. Root a cube is a root a. M square power half is m, we get m cube minus m over 2 times 4 square is 16, a square by m power 4. 32 over 3, root a into root a is a into a is a square divided by m cube minus 8a square over m cube. 8a square divided by m cube is common. We get 4 divided by 3 minus 1. 8a square over m cube. This is 1 by 3. Therefore, the answer is 8a square divided by 3m cube square units. Question 7. Find the area enclosed by the parabola 4y equal to 3x square and the line 2y equal to 3x plus 12. We will solve these two equations. 2 times 2y is 3x plus 12 equal to 3x square. 6x plus 24 is 3x square. We get a quadratic equation. 3x square minus 6x minus 24 is 0. Let us divide by 3. X square minus 2x minus 8 is 0. The factors are x minus 4 and x plus 2. Therefore, x values are 4 and negative 2. We will find y values. Both the equations are having linear y. We can use any one of these two equations. 4y is 3x square. 3 times x square is 16. Therefore, y is 3 fours are 12. And if x is minus 2, 4y is 3 times minus 2 the whole square. Therefore, y value is 3. The points of intersection are 4, 12 and minus 2, 3. 4, 12, minus 2 and 3. The parabola is an upward parabola and it passes through the origin. The equation is y equal to 3x square over 4. And the line also passes through these 2 points. The line equation is y is equal to 3x plus 12 divided by 2. The area is between these 2 curves. We will draw the limit lines. The area is between 2 curves, so we will do upper curve minus lower curve. Let us do integration with respect to x. Therefore, area is integral minus 2 to 4 of upper curve is the line minus integral minus 2 to 4 of lower curve is parabola. Integral minus 2 to 4 of, from the line equation, y is half into 3x plus 12 dx minus integral minus 2 to 4 of y from the parabola equation is 3 by 4 times x square dx, half into integral of x is x square divided by 2 and the limits are minus 2 to 4. Integral of 12 is 12x, the limits are minus 2 to 4, minus 3 by 4 times integral of x square is x cube divided by 3. The limits are minus 2 to 4, half into 3 by 2 times 16 minus 2 the whole square is 4 plus 12 times 4 minus of minus 2 plus 2 minus 1 by 4 times 4 cube is 64 minus 2 the whole cube is minus 8, half into, this is 12, 6 times 18 plus 6 times 12 is 72 minus 1 by 4 times 64 plus 8, 72. 90 divided by 2 minus 18. This is 45, 27 square units. Question number 8. Find the area of the smaller region bounded by the ellipse x square divided by 9 plus y square divided by 4 equal to 1 and the line x divided by 3 plus y divided by 2 equal to 1. Both are in the standard form. Therefore, from the equations itself, we can make out that the points of intersection are 3, 0 and 0, 2. Or you may solve the equations and get the points of intersection. This is 3 and this is 2 and the line also passes through these 2 points. Equation of the ellipse is x square over 9 plus y square over 4 equal to 1 and equation of the line is x over 3 plus y over 2 equal to 1. and we have to find the smaller region bounded by ellipse and the line. The area is between two curves. We have to do upper curve minus lower curve. And for both the curves, the limits are 0 to 3. We will do integration with respect to the variable x. Integral 0 to 3 of upper curve is ellipse minus integral 0 to 3 of lower curve is the line yl dx. We will find y from both the equations. The ellipse equation is y square divided by 4 equal to 1 minus x square divided by 9. Take LCM. Therefore, y square is 4 over 9 times 9 minus x square. Y is 2 by 3 times root of 3 square minus x square. We will take the positive square root because we are using the curve in the first quadrant. Similarly, from the line equation, y divided by 2 is 1 minus x divided by 3. Taking LCM, therefore y is 2 divided by 3 times 3 minus x. Therefore, the area is integral 0 to 3 of y from the ellipse equation. 2 by 3 times root of 3 square minus x square dx minus integral 0 to 3 of y from the line equation. 2 by 3 times 3 minus x times dx. We will use the formula 2 by 3 times x divided by 2 root of 9 minus x square plus a square divided by 2 sine inverse of x divided by 3, and the limits are 0 to 3 for both the terms. We will take 2 by 3 common, so minus 3 times integral of 1 is x and the limits are 0 to 3, minus of minus plus integral of x is x square over 2. The limits are 0 to 3. 2 by 3 times upper limit will become 0, lower limit is also 0, plus 9 by 2 times sine inverse of 1 minus sine inverse of 0, minus 3 times 3 minus 0 plus half into 3 square 9 minus 0. 2 by 3 times 9 by 2 times sine inverse of 1 is pi by 2, sine inverse of 0 is 0, minus 9 plus 9 divided by 2. 2 by 3 times 9 pi divided by 4 minus 9 by 2. 9 divided by 2 is common. We get pi by 2 minus 1. Therefore, the answer is 3 times pi by 2 minus 1 square units. Question number 9. Find the area of the smaller region bounded by the ellipse x square over a square plus y square over b square equal to 1 and the line x over a plus y over b equal to 1. It is a similar question. Both are in the standard form. We can directly write the points of intersection. On the x-axis it is a comma 0 and on the y-axis it is 0 comma b. Let us draw the figure. This is a and this is b. The line passes through these 2 points. Equation of the ellipse is x square over a square plus y square over b square equal to 1, and equation of the line is x over a plus y over b equal to 1. From the ellipse equation, y square over b square is 1 minus x square over a square. Taking LCM, therefore y will be b divided by a times root of a square minus x square. We are taking plus root because we are using the curve which is in the first quadrant. Similarly, from the line equation, y divided by b is 1 minus x divided by a. LCM is a. Therefore, y is b divided by a times a minus x. We will now shade the region. Smaller region bounded by the ellipse and the line. The areas between two curves, we will do upper curve minus lower curve. Therefore, area is equal to, we will do with respect to x variable. The limits are 0 to a, integral 0 to a y of ellipse dx minus integral 0 to a y of line dx. Integral 0 to a, from the ellipse equation, y is b divided by a times root of a square minus x square dx minus integral 0 to a of b divided by a times a minus x dx. b by a is common, and formula for integral root of a square minus x square is x divided by 2 root of a square minus x square plus a square divided by 2 sine inverse of x divided by a. The limits are 0 to a for both the terms. b by a has been taken out as a common factor, minus integral of a is ax and the limits are 0 to a, minus of minus plus integral of x is x square divided by 2, the limits are 0 to a. b by a times upper limit will be 0, lower limit is also 0, plus a square divided by 2 times sine inverse of 1 minus sine inverse of 0, minus a times upper limit minus lower limit is a minus 0 plus half into a square minus 0. b by a times a square divided by 2 times pi by 2 minus a square plus a square divided by 2, which is b by a times a square pi by 4 minus a square divided by 2. A square divided by 2 is common. We get pi by 2 minus 1. Therefore, the answer is AB divided by 2 times pi by 2 minus 1 square units. Question number 10. Find the area of the region enclosed by the parabola x square equal to y and the line y equal to x plus 2 and the x-axis. Let us solve these equations and find the points of intersection. X square is equal to x plus 2. Therefore, x square minus x minus 2 is 0. The factors are x minus 2 and x plus 1. Therefore, we get two answers, x is equal to 2 and x is equal to minus 1. The corresponding y values are y is x square, therefore 4, y is x square minus 1 the whole square is 1. The points of intersection are 2, 4 and minus 1, 1. Let us draw the figure. It passes through 2, 4 and minus 1, 1 and the vertex is at the origin. Let us complete the parabola. The equation is x square equal to y. The line also passes through these 2 points. The equation of the line is y equal to x plus 2. We have to find the area enclosed by the parabola and the line and x-axis. Since it is given that the area is enclosed by x-axis, we have to shade this region. We will draw the limit line. We will take this as area A and that as area B. Therefore, area is A plus B. Area A is integral minus 2 to minus 1 of area under the line with respect to x plus integral, the limits are minus 1 to 0, area under the parabola y of parabola times dx. Integral minus 2 to minus 1 of, from the line y is x plus 2 times dx plus integral minus 1 to 0 of y from the parabola equation is x squared times dx. Integral of x is x squared divided by 2. The limits are minus 2 to minus 1 plus integral of 2 is 2x. The limits are minus 2 to minus 1 and integral of x square is x cube divided by 3. The limits are minus 1 to 0. Half into upper limit minus lower limit. 2 times upper limit minus lower limit plus 1 by 3 times upper limit minus 1 the whole cube is minus 1. Minus 3 divided by 2 and minus 1 plus 2 is plus 1. 2 times 1 and plus 1 by 3. 6 is the LCM. Minus 9 plus 12 plus 2. 14 minus 9 divided by 6. 5 divided by 6 square units. Question number 11. Using the method of integration, find the area bounded by the curve absolute value of x plus absolute value of y equal to 1. If we remove the absolute value signs, we have to write plus or minus. So we have 4 combinations, both positive, both negative, x positive, y negative, x negative and y positive. So let us draw all these 4 lines. If x is 0, y is 1. If y is 0, x is 1. And for the second line, if x is 0, y is minus 1. If y is 0, x is minus 1. And the third line, if x is 0, y is minus 1. If y is 0, x is plus 1. And the fourth line, if x is 0, y is 1. If y is 0, x is minus 1. The first line passes through 1, 0, 0, 1. X plus y equal to 1. The second line passes through 0, minus 1 and minus 1, 0. This is minus x minus y equal to 1. The third line passes through 0, minus 1 and 1, 0. X minus y equal to 1. And the fourth line passes through 0, 1 and minus 1, 0. Minus x plus y equal to 1. We have to find the area bounded by these lines. And the area is symmetric about x and y axes. Therefore, we will calculate this one area and multiply it by 4. The area is symmetrical about x and y axis. Therefore, the area is, it is area of the square. We will do 4 times A area, 4 times. We can do integration with respect to the variable x or y. We will do with respect to x. Therefore, 4 times integral 0 to 1 The line is x plus y equal to 1, from which y is 1 minus x dx. 4 times integral of 1 is x minus integral of x is x square divided by 2. Upper limit minus lower limit. 4 times 1 minus half is half. Therefore, the answer is 2 square units. And easily we can check the answer, area of the square or area of the right triangle into 4.